Right now, Tabby's star is still going dark, in ways no one on Earth can explain, and NASA has no way to stop it. It is swallowing its own light, dimming without warning, sometimes by 20% in a single day. The best astronomers at Caltech, Harvard, and the Allen Telescope Array have been watching for over a decade with zero answers. But here's what nobody is telling you: the dimming is getting worse. KIC 8,462,852. That is its catalog number. Most people know it as Tabby's star, named after astronomer Tabetha Boyajian, who first flagged the data and could not sleep after what she found. It sits about 1,480 light-years away in the constellation Cygnus, close enough to study in detail, far enough that we will never reach it in any lifetime. It is an F-type star, slightly bigger than our Sun, slightly hotter. The kind of star astronomers barely glance at, except for one thing. In 2015, citizen scientists combing through data from NASA's Kepler telescope noticed something impossible. This completely ordinary star was doing something no other star in Kepler's entire survey of 150,000 stars had ever done. It was flickering, randomly, wildly, in patterns that broke every model science had built to explain them. When a planet crosses a star, it blocks roughly 1% of the light, maybe 2% for a very large planet. Clean, predictable, round. Tabby's star blocked 22%, not once, not twice. It dipped repeatedly at irregular intervals in asymmetric shapes that no known planet could produce. The dips lasted days, some lasted weeks, and then the light came back, partially, not all the way. Something is orbiting this star, something enormous, something with an irregular edge, and whatever it is still crossing in front of that star right now as you watch this. NASA pointed Hubble at it. The Swift Observatory tracked it. Ground telescopes on 5 continents have been logging every flicker for years. And here is the part that stops scientists cold. No one can agree on what shape the blocking object even is. The first explanation was comets. A massive swarm of comets, thousands of them, breaking apart and trailing debris across the star's face. It would explain the irregular shapes, the unpredictable timing, except the infrared did not cooperate. A comet swarm that large would heat up and glow. It would leave a thermal signature detectable from Earth. Spitzer looked. Nothing. The infrared was clean, which means either the comet theory is wrong or whatever is out there is cold in a way that defies everything we know about cometary material. Then they tried dust, interstellar dust clouds, warped disk remnants. Every model produced the wrong dip shape, the wrong duration, the wrong pattern. The obvious explanations are dead. What remains is not comfortable. Here is the open loop you have been waiting for. Long-term records, photographic plates going back to the 1890s. Astronomers dug through over a century of archived data and found something that was not supposed to be there. Tabby's star has been getting dimmer for over 100 years, not just flickering, fading. Slowly, steadily, across more than a century of observation, this star is losing light it is not getting back, by roughly 0.34 magnitudes in that window, and in some analyses, the rate of that long-term fading is accelerating. No natural process does this cleanly. Stars do not quietly eat their own light over a century and then suddenly begin flickering by 20% in a single day. But here is the strange part: it should not be possible at all. If the blocking object were solid, a rigid structure, a swarm of artificial collectors, anything with a hard edge, the dimming profile would be symmetric. It is not. If it were gas or plasma, the spectral signature would bleed into the wavelengths we measure. It mostly does not. The data from Tabby's star contains contradictions that point in opposite directions simultaneously. Whatever is happening out there is behaving like nothing in our catalogs. And when researchers model it forward, projecting the dimming rate decades ahead, the numbers lead somewhere the papers do not finish saying. Physics assumes stars obey rules, that we can model them, predict them, account for every photon they lose. Tabby's star does not obey the rules. That matters well beyond one anomalous star 1,480 light-years away. It matters because of what it implies underneath the entire field of stellar astrophysics. If a star can dim in these patterns, over this timescale, and global science cannot name the mechanism after a decade of concentrated effort. Then there are categories of phenomena in this universe that we have not even imagined yet. The James Webb Space Telescope has trained its instruments on Tabby's star. It sees wavelengths Hubble could not. It is collecting data right now. And the researchers waiting on those results are not using words like hopeful. They are using words like bracing. So here is the question nobody has answered. If it is not dust, not comets, not any natural process with a name, then what is blocking the light? Something out there is dimming a star in a way that breaks every model we have built. And it is still doing it. Right now, what do you think is out there?